Alright, so starting with day 2, so we're going to be doing a continuation of what we did in day 1. So we're looking at sequences and sums. So sequence is going to be a list number. When we start talking about sums, that's going to be adding our list, our sequence, our list of numbers, adding those numbers up. So first thing I want to talk about is reviewing or learning factorials if you've never worked with factorials. So guys, factorial, if we just have one factorial, that is just going to be 1, okay? 2 factorial is 2 times, what you're doing for factorial is you take the number that they give you and you're counting down, but you're multiplying those together. So 2 times 1, which will give us 2. Then we have 3 factorial, which is 3 times 2 times 1, which will give us 6. And then 4 factorial, which is 4 times 3 times 2 times 1, which will give us 24. 5 factorial, 5 times 4 times 3 times 2 times 1, which is 120. And it keeps going on forever, but we're only going to go to 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, which is 720. So, these factorials could be written somehow as, think about maybe a recursive formula, because you take the previous term and you keep multiplying it, okay? So, the reason that we're going over factorials mainly is so that you can spot these out. So, sometimes they'll use, when you're looking for patterns, if you see these numbers, 1, 2, 6, 24, 120, 720, if you spot those numbers out, you can know that they're meaning a factorial in your patterns. Okay, so in general, so if we're not talking about numbers, but we're talking about letters, if I say n factorial, this means you're going to count down. So we have n, the next term would be n minus 1, because that would be the term before it. Then it would be n minus 2. Then it would be n minus 3. And that would keep going on forever until you ended up back at 1. Because remember, you always count down, okay? So that's what that means. So we just have some problems that we want to simplify. So we have 5 factorial over 7 factorial. So if you want to simplify, you want to pick the biggest number to rewrite. Okay. So I'm going to keep the 5 factorial just like it is. And I want to rewrite 7 factorial. Well, you know you start with the 7 and you're going to count down. So 7 times 6 times, because I am at this 5 here, I could keep going. But I could stop and write 5 factorial, and that would mean the same thing. The reason I'm going to do that is because now these 5 factorials can cancel. We'll just have 1 over 7 times 6, which is 42. So we would get 1 over 42. Okay? So the one to the right of that, 12 factorial times 9 factorial. So I want to rewrite the bigger one, so we're going to rewrite 12 factorial, and we're going to rewrite it until we get to 9. So 12 times 11 times 10 times 9. I'm going to stop there and make it factorial. Keep my 9 factorial on the bottom. So I can cancel out my 9 factorial. So I just have 12 times 11 times 10, which would be 1,320. And then the last one is with variables instead of numbers. So we have n factorial over n plus 2 factorial. So just like with the numbers, you want to pick the bigger one. So is n bigger or is n plus 2 bigger? So think about this. Is 10 bigger or is 10 plus 2, 12 bigger? Well, n plus 2 is bigger. So we're going to keep the numerator just like it is. We're going to rewrite n plus 2. So I'm going to start with n plus 2. If I subtract 1 from n plus 2, that's going to be n plus 1. If I subtract 1 from n plus 1, that's going to be n. Well, that matches the top, so I'm going to stop there. So now my n factorials cancel. I just have 1 left in the numerator. And in the denominator, I have n plus 2 times n plus 1. Okay, so that was just a review of factorials. That really had nothing to do with sequences there. We're going to see how it can relate to sequences in a second. But factorials, you just take the number and you're counting down and you're multiplying all those numbers together. So let's see how this relates to yesterday. So we want to write an explicit formula. So if we can relate it to the formula sheet, we can use the formula sheet. If not, we're going to have to just come up with a pattern. And we want to assume that it begins at 1. So for the first one, we have 1, 2, 6, 24, 120. So I would always try to use your formula sheet first, just because that way you don't have to think of this pattern on your own. So if I try to add 1, but then this is adding 4, so arithmetic's not going to work. And then geometric, if I multiply by 2 here, but then multiply by 2 here, it gives me 4 and not 6. So those are not going to work. But if you notice, 1, 2, 6, 24, and 120 look like those factorial numbers. So think about this. First term is 1, 2. Guys, if you ever have to come up with your own pattern, I highly suggest writing these in values underneath because it will help you relate. Well, if you look back to your factorials, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. So that means my explicit formula for my sequence is just going to be in factorial, okay? And if you want to try it out, like if I do a sub 4, if I plug in 4 factorial, well, that does give me 24, which works. So then if we look at number 2, we have 1, 3, 3 squared over 2, 3 to the third over 6, 3 to the fourth over 24. Okay, my first suggestion to you here is to make all these be fractions. So go ahead and just put this over 1. That way, and see what's going on. Because we have fractions here, you can look for the adding and subtracting. A lot of times, because you have 2 things going on here, sometimes you just look at the numerator, just look at the denominator, see what's happening. So if we just look at the numerator, you can think about that they're multiplying by 3, or we can just come up with a pattern. And then if you look at the denominator, hopefully you're kind of seeing the factorials. So before I do anything, I'm going to label this n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. And I am just going to look at the numerator right now. Okay, so I have 1, 3, 3 squared, 3 to the third, 3 to the fourth. So it looks like everything's getting 3 to some power. But if I just do 3 to the nth power, okay, let's try that out. If I do a sub 2, that's going to be 3 squared on top. But look, a sub 2 just has a 3 on top. So sometimes these n values get off a little bit. So a lot of times to fix this, if you make this n minus 1, it'll work. So let's try this. If I do a sub 2, that would be 3 to the 2 minus 1, which would just be 3 to the first, which is 3. Well, that works for that one, okay? So 3 to the n minus 1 is what I need in the numerator. So now we're going to take a look at the denominator. So the denominator has our factorial pattern here. Okay, it has that 1, 2, 6, 24. But it has this extra one. So thinking about if I just did in factorial, I'm going to just write this up here. If I just do in factorial here, let's do the second term again. If I do a sub 2, and I'm just going to do the denominator, but this would be 2 factorial, which will give me a 2 in the denominator. But if you look at the second term, it only has a 1. So we're also going to do the n minus 1 thing here. So we need to rewrite this as n minus 1 factorial, and let's see what happens there. So now if I do a sub 2, in the denominator it would be 2 minus 1 factorial. We know 1 factorial is just 1. So that is right, okay? Just a statement here, you need to make sure you know 0 factorial is 1, even though it seems like it would be 0. But that is a statement that you need to make sure that you understand, because it will make a lot of these make more sense. So this right here is my explicit formula. I am just going to check it one more time just to make sure with a different term. So I'm going to do like plug in a sub 4. This would be 3 to the 4 minus 1 over 4 minus 1 factorial. So that would be 3 to the third over 3 factorial, which would be 3 to the third. We know that 3 factorial is 6. Well, that is exactly what I'm supposed to get for a sub 4. Okay, so always, once you make your formula, go back and check just to make sure that you're on the right track. Alright, so we got 2 more examples like this. So we're trying to write an explicit formula. Just down a little bit. So you do have fractions here, 2/3, 3/5, 4/7, 5/9, 6/11. And they're all fractions already, so you don't have to worry about changing them yourself. Okay, so if you try to go from 2/3 to 3/5, 3/4 to 4/7, there's no common. You can't add anything to get there. You can't subtract anything to get there. So we're just going to look at the numerator, and then we are just going to look at the denominator. So if you just look at the numerator, okay, and if you want to write it separately, you can, but I'm just going to look at the numerator. How are we getting from term to term here? Well, we're adding 1 from each term. So for the numerator here, we are adding 1, which means that's our arithmetic sequence, which means I can use my formula to get my explicit. So for the numerator here, I'm going to use, so this is arithmetic, so I can use my a sub n equals a sub 1 plus n minus 1d. Okay? So for just the numerator, a sub n equals, the first term is 2. We keep our n minus 1. The common difference is what you're adding each time, so that's going to be 1. So if we simplify this out, 2 plus n minus 1, so a sub n is n plus 1. So this is what's going to be for the numerator. Okay? So now let's look and see if the denominator has a pattern. So if you look at the denominator, we have 3, 5, 7, 9, 11. Okay, well that's good. We're adding 2 each time. So it's still going to be arithmetic, so we can use the same formula on the formula sheet. Well, for the denominator, we have a first term of 3. And then for the common difference, we're adding 2. So then we can distribute that out. So we're going to get a sub n equals 2n plus 1. So what I did is I did these separately. So we have our numerator and we have our denominator. So we can put this all as 1 now. We can say a sub n equals n plus 1 over 2n plus 1. Now I want to take time to check this. So I'm going to do, this would be the first term, second term. I'm going to do the third term. So if I do a sub 3, this would be 3 plus 1 over 2 times 3 plus 1, which would be 4 over 7, which is exactly what I got for the third term. So that just shows you, you can double check and make sure that you're going to end up with the correct answer once you make your explicit formula.